Hello mathsy people, Mr. Hanny here, taking you through solving simultaneous linear and quadratic equations. Okay, so let's have a look at what this is kind of looking like graphically. So we've got a quadratic equation here in blue and a linear equation here in red. And what a simultaneous equation means that you've already seen before with two simultaneous linear equations is it's just the point of intersection between their graphs. In other words, it's the point in which both equations, both this equation and this equation, both are true at the same time. So in this case, it's going to be here, they're both true right there, and they're both true right here at this point of intersection as well. So when you've got one linear equation and one quadratic equation, you can see that here in this example, there are 2 points of intersection, so there will be 2 solutions. Now, let's look at another example. Here's another one. We've got a quadratic here in black and a linear equation here in pink. And here you notice there's only one solution. The linear equation only just touches the quadratic or the parabola. In other words, it's a tangent line to the parabola at this point, which is x equals 0. So there's another case where there's only one solution, and finally, it's possible that there might be no solutions, like in this case here. So in this video, I'm going to go through those 3 cases, and we're going to solve those both algebraically and also using our CAS system. So first, let's look at this equation here, and let's look at it first off just with the CAS calculator. So perhaps I'll go through all three examples with the CAS first. So it's fairly easy to find a point of intersection. What we're doing is analysing these graphs, and we're looking for the point of intersection number 4 here. So once the lower bound, so up there and upper bound here, and there's our point of intersection, it's 0, 3. Okay, that was pretty easy. Let's find the other point of intersection. Analyze this graph. Point of intersection. Here's our lower bound, upper bound over here. There we go, 4, negative 5. That one. So that was pretty easy. Let's try this one here. So once again, analyze these graphs, points of intersection. And there we go, 0, negative 3 for that one. And if we go into this graph, we might try to use the point of intersection. Let's just try it. And whoop, no intersection is found. No surprises there, because it's quite clear they do not intersect. So be warned, sometimes it will appear as though there's a point of intersection, but they won't actually be quite touching. So it's always best to just check to be sure. Okay, so that's using the CAS, extremely easy. Now let's do it algebraically. Okay, whoops. So this first example, we have 2 equations. Let's write them both out, and they both need to be in the standard expanded form for any polynomial. So that's this form here where we've got y equals, whoops, sorry about this, x squared minus 6x plus 3. That's our quadratic, and our linear equation is y equals minus 2x plus 3. There we go.